Myself Vipin Gopan. I am working as the Assistant Professor in Trinity College of Engineering. I am here going to take a small lecture on the very basic concepts of thermodynamics. Some of you may wonder why I am sitting here with a cup of coffee, sugar, induction heater, kettle of water, etc. Usually the professor starts a lecture with a PowerPoint presentation or any other teaching aids. But here I am using all these things. Why is because of two reasons. One is I can explain some basic concepts of thermodynamics using all these things, and the second, which is the most important thing, is I want to show you that thermodynamics is in your daily life. Whatever activities you come across in your daily life, you can see the application of thermodynamics. To show that only I am using all these things. Okay, now let's start with a sip of coffee. Nice coffee. Actually, the credit goes to my wife, but I am a mechanical engineer. Precisely, I am a thermal engineer. So I am not concerned about the quality of this coffee, rather about the temperature of this coffee. Why temperature? I will come later. Now, thermodynamics actually divides the whole universe into two basic things: system, surroundings. The region where our study is concentrated is the system. System means the region where our study is concentrated. In this case, this cup of coffee constitutes the system. Anything outside the system constitutes the surroundings. So, the system plus surrounding is equal to universe. In this case, this coffee is the system, this cup of coffee is the system, and the whole universe except this cup of coffee constitute the surroundings. Now you understand the very basic concept of thermodynamics, that is the system and surroundings. Without understanding without understanding the system or surrounding, you can go further deep into the thermodynamics. Again, system can be classified into open system, closed system, isolated system, etc., etc. But because of the time limitation, I am not going into that much details. I am again coming back to the temperature of this coffee. Assume coffee is at a temperature of 60 degrees Celsius. Surroundings at a temperature of 30 degrees Celsius. What will happen? An energy will flow from high temperature body to lower temperature body, that is from this coffee to surroundings. Because coffee is at a temperature of 60, surroundings is at a temperature of 30, so a temperature difference is there, and therefore that energy will flow from coffee to surroundings, which is called as heat transfer. Because in this case, temperature difference is the only reason for this energy transfer. If temperature difference is the only reason for energy transfer, that transfer of energy is called as heat transfer. This is the definition of heat. Energy transfer because of temperature difference. Okay, so now you understand one of the two fundamental concepts in thermodynamics, that is the heat transfer. Now I am going into the next part. Before going, again I will have one more sip of coffee. Still a nice one, but I am in my 20s, that means I don't have any diabetes. I feel I should add one more teaspoon of sugar. Okay, what I did is I add one more teaspoon of sugar so that the added sugar dissolved in this coffee and the coffee get much sweeter. If I ask this process to my wife, she will also explain in the same way only. But I already told you I am a mechanical engineer. I am not going to view this process in this way. Rather, I am looking from the thermodynamics perspective. Actually, what I did is I transfer some amount of energy or some form of energy into the system through the stirring action. some energy is transferred into the system through the stirring action. This energy transfer is called as work, because here I transfer the energy through the stirring action. It can be a stirring action, or it can be an external motor, or it can be a paddle wheel, or it can be any other external agency, or it can be any other means, but not the temperature difference. In the earlier case, the temperature difference is the reason for energy transfer, which is the heat transfer. But in this case, any reason other than temperature difference is the reason for energy transfer. This is called as work. So now you understand what is heat and what is work. Now let's start with the formal definition of heat energy or heat transfer and work transfer. How you can define heat transfer? Heat transfer can be defined as an energy transfer across the boundary of the system on account of temperature difference. Whereas work transfer means energy transfer across the boundary of the system on account of reason other than temperature difference. That is the key thing, temperature difference other than temperature difference. Even though these two seems to be entirely different, but there are a lot of similarities between heat and work. The main similarity is both are form of energy in transit, which means that both heat transfer and work transfer will have a value only when it crosses the boundary of the system. And energy transfer within the system can't be considered as heat or work transfer. Energy transfer within the surrounding can't be considered as a heat transfer or work transfer. Energy transfer, when only the energy transfer across the boundary of the system is called as heat or work transfer. Again, if you go further deep into the work transfer, you can see lot of varieties of work transfer. See, this is another example. Here I am switching on the induction heater. There is a kettle with water, and what will happen? The temperature of the water will increase. Here also I am not transferring the heat because temperature difference is not the reason. Here I am transferring the work through electrical means. Here electrical energy is transferred into the system, but it is work transfer. This is called as electrical work. Similarly, there can be shaft work, there can be mechanical work, or there can be lot of varieties of work. I am not going into that much details, and more importantly I am switching off the induction heater. So I hope you understand the basic concepts of heat and work, which are the foundation from which the whole thermodynamics is built. I told you thermodynamics is a very interesting subject actually. Whatever you found in nature can be related to thermodynamics in some way. It's a very beautiful subject, and also it's a most powerful subject in engineering. Why? When you go deeper into thermodynamics, that is when you reach second law of thermodynamics, or when you go through entropy, you can feel the power of thermodynamics. So I hope you build from this foundation. I just throw light into some few concepts of heat and work. Start building on thermodynamics from this foundation. Hope you enjoyed the session on thermodynamics. Thank you for spending your time. Thank you.